So today we're going to talk about circles. We're going to talk about the arc measure, the arc length, and the circumference. So before we talk about circles, we need some definitions. Oh boy.
It's round.
It is round. That is true. So according to the way this circle is labeled, it would be called circle D, because we always label it by the center point. And just like with a triangle, you have to actually draw a small triangle out front to say, hey, we're talking about a triangle. We would talk about circle D. Guys, George, I need you to be quiet. Why do you think I put a dot in the center of my circle? Okay. No, just because I want to know that's a circle and not the letter O or 0. Yeah. This symbol means circle D. I am talking about circle D. So, Daniel. Radius. What do we know the radius is on a circle? What does radius mean? Half the diameter. Edgar. I think someone else gave a definition, but I couldn't hear.
What?
No, he was just chatting, and I told him to be quiet. Okay. So radius is half the diameter. What else do we know about the radius of a circle? It goes from the middle to the outside. So radius is from the center to the outside. It's half the diameter. Last warning, George, and then I'm going to have to move you. Can anyone name some of the radii, that's just plural for radius, radii on this particular circle, on circle D? What is one of the radii? A to what? D. BD would be a radius.
DC.
CD. Or I could say DC, BB, DA. It could be in the opposite order. Those are all radii. What about the diameter? What do we know about the diameter of a circle?
That's the full length.
The full length of the circle. It's the line that goes all the way across the circle.
Is that from June card?
Angelica is not here today. Okay. So a line that goes all the way across the circle through the center. Can anyone name a diameter?
AC.
A to C, or I could have said CA. Doesn't have to be in that order. A to C is the diameter. What about circumference? What do we mean by the circumference of a circle? Around the entire outside. It's the distance on the outside of the circle. Does anyone remember the formula for circumference?
Isn't it diameter times 2?
Close. Diameter times. Closer with 3 though.
Radius.
Pi.
Pi.
Or, we know diameter is twice the radius, so I could also say circumference is 2 times r times pi. Because 2 times r is the same thing as diameter. So those first 3 definitions are definitions you should have seen before with circles. The next definitions should be newer definitions that you haven't seen before. So our first new definition, Ellie, is central angle. What do you think I mean by central angle? Central means center. Angle is 2 lines that meet. So central angle, I could have a couple of examples, but if I started at B, went to D, went to C, that would be considered a central angle. Or I could do ADB. ADC would also be considered a central angle, as long as we start on the outside edge of the circle, hit the center, and then hit the outside somewhere else. That's our central angle. So it's angle going through the center of the circle. Again, I could name one of these. Angle ADB would be a central angle. Or the one I had highlighted, angle BDC, would be considered a central angle. So again, that should be a newer definition, something you haven't seen before. And then arc. What do you think I mean by arc? What do you think I mean by arc? Okay. Daniel's holding up his hands to form a piece of a circle. Okay. An arc is just a piece of a circle. Shut the door really quick. So an arc has its own way to write it, just like angle has its own way to write it, or circle, or triangle. So the arc would be a piece of a circle. If I highlight that blue arc, what letters do you think I would use to name that blue arc that's on the outside edge of the circle?
CDB.
Okay, just BC, because we're only thinking about the outside edge, not the inside stuff. So BC. And just like a line segment has a line drawn above it to say, hey, this is a line segment, an arc will have an arc drawn above it to say, hey, this is an arc. So BC with an arc drawn above it says, hey, this is an arc. And we have 2 kinds of arcs. We have a minor arc and a major arc. Why do you think we would call an arc a minor arc versus a major arc?
Because one is bigger than the other.
One is smaller, one is bigger. A minor arc is less than 180 degrees. A major arc is more than 180 degrees. Then I've got to scroll back to the picture. I'll let you write that down first before I scroll back to the picture. Because we have to talk about how to label a major arc. Does everyone have this written down so I can scroll back up? Not quite yet. Okay, I'll give you like 30 more seconds. So looking at my picture, we'll scroll back down in a second to write down our major arc. Looking at my picture, if I wanted to name a major arc, if I wanted to start at B and end at C, but go in the red direction instead of the blue, we already said the minor arc is BC. So I can't call that major arc BC again. Okay? Hannah knew exactly what to do. She said, well, let's add another letter so that we know exactly what direction we're going. If I said BAC, that would define my major arc. So my major arc needs 3 letters. Because we have to know what direction we're going in for the major arc. If there's 2 letters, you assume the shortest distance between those 2 letters. If there's 3 letters, you have to pass through that middle letter. So there's a few more definitions we're not going to write down, but you'll see on the assignment. Does anyone know what a concentric circle is? Have you guys seen like a target for darts or for shooting? Okay. Concentric circles are circles that are inside each other. Does anyone know what I mean by a semicircle? What would a semicircle be? Half of a circle. And then, what would I mean by, Chris? Still need you to be quiet. Anyone know what I mean by adjacent arcs? What does adjacent mean? Next to. Okay? So it would be 2 arcs next to each other. Okay, so we have a couple examples to go through. So there's a lot going on in this circle. This is actually a D up here. It's like the letter D. So, we need to talk about the difference between arc measure and arc length. So arc measure is saying how many degrees does it take to make this arc. So arc measure guys, shh. I need you to quiet down, please. Daniel. Arc measure, how many degrees is used to make an arc? And it's just given by that central angle that's inside that goes with the arc on the outside. So I asked first about the measure of arc AE. So I want to know about this arc starting at A, going to E. We assume the shortest distance unless I use 3 letters. Arc AE. What angle do you think goes with arc AE? 95. 95 goes with arc AE because the lines used to make up 95 are what also make up that arc. So the measure of arc AE just matches the measure of that central angle. Measure of arc AE is 95 degrees. The central angle that goes with the arc, they're the same measurement. What about EB? Okay. EB starts here, goes all the way to here. That's still a minor arc, it's still less than 180, even though we passed through A, still less than 180. But I need more than just the 95 to determine the measure of that arc. What else do I need besides the 95?
30.
The 30. What do you think I should do with those two values? Add them. So we'd have 95 plus 30, 125 degrees. What about DE?
Oh, dang it.
Unknown.
D to E.
I had it the other way around.
Braden. D to E. I don't have an angle measure in there. Guys, I need you to quiet down again. We're still doing notes.
How much longer?
Just quiet down till notes are over. Okay?
Are we close?
So,
Isn't it you minus it from 180?
good. A couple of people up front said that as well. Hannah and Carly both said that. They said, well, let's minus from 180. What are we minusing from 180?
95.
95. Why would we do that?
Was that the circle?
It's half the circle. How much is half a circle? 180. Or a straight line is 180. So if we do 180 minus 95, we can find this angle measure. So we get 85 degrees. What other degree measures do we know about circles? Besides a half circle, how many degrees are in a full circle? 360. So I could find BC now using 360 if that was asked about. So the measure of angle DE is 85 degrees. So that's arc measure. Arc length is still talking about an outside piece of a circle. Chris, will you move away from your table for the rest of the notes? Daniel, stop throwing papers. Okay? Arc measure was how many degrees. Ellie, I really hope you're not playing on your phone. Sade, you need to quiet down. Arc measure was how many degrees? Arc length would be the actual length of the piece of the circle. If we laid a piece of string down and then pulled it straight, we could measure it with a ruler or a tape measure. So arc length is the actual length along the outside edge. Now, arc means it's not the entire circle, it's just a piece. So, we need a formula for this. We know our circumference formula, but that gives us our entire circle. We don't want the entire circle, we want just a piece. So the arc length formula is theta times r times pi over 180. Arc length would be theta. What do I mean by theta? Angle. Theta is commonly used to represent an angle. What do I mean by r? Radius. Pi is 3.14. 180, just a number. You don't need to know what those mean. So arc length, we needed a formula. Arc measure was just our central angle. So we're going to try a problem. Chris? We're going to try a problem where we find the arc length instead of the arc measure. Edgar,
I'm listening.
I don't want you to be talking, even if you're listening. I'm glad you're listening, but I also want you to be not talking so other people can also listen. Okay, so I want to find the arc length of x, y on this circle. I want to find the arc length. This says 8 centimeters here. That's 8 centimeters. It got a little squished. So I want to know the arc length, not the arc measure. The arc measure would be super easy. What's the arc measure of x, y? 40. We look at the central angle. The arc length, we have to go use this formula. So our formula says, start by plugging in the angle. What's my angle for that arc? 40. Times the radius. What's the radius of my circle? 8 centimeters. We'll just put an 8 times pi over 180. We'll write centimeters at the very end for our units at the end of this problem. Okay, so the question is, how do I want you to write this? When you simplify this, I want pi to stay in the problem. Your final answer should have pi in it. Okay. Mathematicians like things exact. Using 3.14 isn't super exact, so we're just going to leave the symbol pi. Which means I really just have to deal with this stuff and simplify this stuff. So first I'm going to multiply the 40 times 8. Gives me a little less going on. That would give me 320 pi over 180. Again, I'm still dealing with just the fraction in front. I want to reduce that fraction. What are some things that could divide into that fraction? 2. What else? 10. Anything else? 20. We want to use the biggest. So we're going to start with 20. If we need to, we could simplify again. 320 divided by 20 is 16. 180 divided by 20 is 9. So we need to consider again 16 over 9.
3.
Is there anything that divides into both of those?
No.
You might think 3 because
Oh,
3
wait,
is really
never mind,
close,
never
but
mind.
3 doesn't go into 16. So we're going to leave our answer exact for this problem. Oh, I should write centimeters as my units though. Yep, 16 pi over 9 centimeters. You reduce your fraction as much as you can.
That wasn't too bad.
We just have one last problem. Did everyone get that written down though before I
Yeah.
scroll all the way down? Last example, Liam's bicycle.
Okay, just write bike for short.
Sure, Liam's bike's wheels. I know that is probably horribly grammatically incorrect, but oh well. Liam's bike's wheels, there's a lot of plural on that. Have a have a diameter of 3 feet. I wasn't exactly sure if that was an actual bicycle wheel measurement. Seemed a little large, but I wasn't 100% sure because I don't write it back.
You got them 24 inches. Go with it.
Okay. How many feet will Liam have traveled when he has done 2,000 revolutions? What do I mean by revolution, first of all? How many times the winds spin around? I was trying to combine the words spin and wheels. Spiels.
You know, I know.
Okay? Revolutions. How many times the wheels spin? So we want to know an actual distance traveled. How would I find just one revolution? How would I find how many feet I travel by doing one revolution? Okay. We would go find the circumference. If I have a circle and I want to know the distance from one revolution, here's my point I start at. One revolution is all the way around the circle. I just need to find circumference. So we had two formulas for circumference. 2 r pi, and d times pi. Which one should we use? D times pi because they gave us diameter. So diameter is 3. So diameter times pi is 3 times pi. So 3 pi. And we need to be quiet for like 1 more minute. But that's only 1 revolution. How am I going to find his total distance if he did 2,000 revolutions? Times it by 2,000. We could add 3 pi 2,000 times.
Still traveled wrong, which I'm insane.
It's only 1 L, isn't it? I always do that.
Okay, nobody's
Thank
perfect.
you. Well, I'm not an English teacher. Okay. So the total distance would be 3 pi times 2,000. Now, last time I wanted you to keep it exact. Last problem I said, let's keep it as this, 6,000 pi. This time where we're doing a word problem and we want a little more understanding of what the word problem is meaning, Braden. This time I want you to actually multiply it out in your calculator. So you can use 3.14 for pi, or I think most calculators have a pi button, even the calculators on your phone. Okay. So I want you to multiply 6,000 times pi. 18,849, wasn't it 0.6 or 40? 40 or 49?
49.
49? Okay. The actual pi button, so see how if you use 3.14 it can be a little off. 49.6 feet. Now, most word problems should make some logical sense. Is that possible to go on a bike? Sounds like a lot. 18,849 feet.
Yeah.
How many feet are in a mile? 5,280. I heard it over here somewhere. So he went a little over 3 miles. Is that feasible on a bike? Yeah, that's actually a pretty short bike ride. So make sure your problems make logical sense when you're doing a word problem.